NASA experts have witnessed water molecules on the moon, and the implications are out of this world. Hit the subscription button and ring the notification bell. This way you'll be the first to learn about the updates that appears on Inspiring Stories several times a day. For years, it was believed that the moon was devoid of any significant surface water. As a result, it seemed unlikely that our planet's sole natural satellite would be capable of supporting life. NASA scientists have now found definite evidence of water, however, which could have major implications for the future of space travel. It's safe to say that the moon has been an object of human fascination for many thousands of years. It was only with advances in science and technology in the 20th century, though, that we were actually able to get close to the astronomical body. And even though we're still learning new things about the moon all the time. It was the Soviet Union that first set its sights on the moon in the 1950s. And in 1959 the country succeeded in coming close to the interplanetary body with their spacecraft Luna 1. The Russians went a step further that year when Luna 2 became the first man-made artifact to reach the moon. And it was also in 1959 that Luna 3 took the first ever photos of the far side of the moon. In the next decade, space exploration advanced at a dizzying speed. After the Soviet Union launched the first man, Yuri Gagarin, into orbit in 1961, President John F. Kennedy promised the United States would land a man on the moon before the 1960s were out. And over the next few years, both the US and the Soviet Union conducted a series of unmanned missions to the moon in order to learn more about the strange lunar landscape. During this period, scientists gathered information about the moon's environment. As a result, they discovered that the lunar landscape featured many craters of different sizes and was covered by a fine dust. Researchers also learned that the moon was made up of rocks not dissimilar to the ones on our own planet. But unlike Earth, it had no atmosphere or magnetic field. Human exploration of the moon really got underway in late 1968. It was then that a manned Apollo 8 flight orbited the moon for nearly 24 hours. This was the first occasion upon which the lunar landscape had been viewed by humans from close up. However, it would be another 7 months before man would successfully land on the moon. It was on July 20, 1969, that Neil Armstrong and Buzz Aldrin, crew members of Apollo 11, famously touched down on the moon's Sea of Tranquility. They explored the lunar landscape on foot for a couple of hours, picking up rock samples as they went. Through them, scientists later concluded that the darker regions of the moon were formed by ancient volcanic lava that solidified more than 3 billion years ago. The rock samples that Armstrong and Aldrin collected were found to be broadly akin to those on Earth. However, they were much drier in their composition, and this suggested that there were no great reserves of water on the moon. Moreover, it seemed likely that there never had been. That being said, some scientists still believed that there was indeed water present on the moon. But it wasn't until the 1990s that their theory got some backing in the form of evidence. It was then that the Clementine spacecraft found some proof that water in the form of ice could exist in the south pole of the moon. This point is constantly in shadow, meaning that water there doesn't evaporate due to exposure to sunlight. Water cannot exist on the surface of the moon in liquid form. That's because, in the lunar environment, the molecules basically evaporate and escape into space. Therefore, from the 1960s onwards, scientists have suggested that only ice water could be present in the moon's poles. Although scientists had theorized about the presence of ice pockets on the coolest areas of the moon for decades, it wasn't until 2018 that these were confirmed. It was then that researchers finally found definite proof of water in the form of ice on the lunar surface. They also discovered that the deposits were sporadic in their locations and suggested that the ice could have ancient origins. For the first time, then, scientists could also accurately map the location of the ice deposits. As expected, they were indeed confined to the poles of the moon. At the south end, water was mainly found in lunar craters. Meanwhile, in the north, ice was more distributed over a larger area. In the most remote parts of the moon, here, conditions are very harsh, with the highest temperatures failing to reach more than -250 degrees Fahrenheit. Furthermore, due to the moon's axis being slightly tilted, the regions that contain ice are never touched by natural light. Heading the research group behind this important discovery was Shuai Lee from Brown University and the University of Hawaii. He worked alongside Richard Elphick, who is based in Silicon Valley, California, at NASA's Ames Research Center. Together with their colleagues, they used special NASA technology, known as the Moon Mineralogy Mapper, to demonstrate that ice could indeed be found on the lunar surface. Explaining his team's discovery in a statement obtained by CNN in August 2018, Lee said, "We found that the distribution of ice on the lunar surface is very patchy, which is very different from other planetary bodies such as Mercury and Ceres, where the ice is relatively pure and abundant. The spectral features of our detected ice suggest that they were formed by slow condensation from a vapor phase, either due to impact or water migration from space." The Moon Mineralogy Mapper, often referred to by its shortened name, M3, was launched into space in 2008. It was carried by an Indian spacecraft called Chandrayaan-1 and designed with the sole purpose finding ice on the moon. With that in mind, it could detect the reflective qualities of ice and also gauge how that ice reacts to infrared light. That allows it to tell the difference between vapor, liquid water and ice. In a statement on its website, NASA pointed out that, while other research had uncovered potential evidence of surface ice near the moon's south pole, the data from M3 offered definitive proof. The discovery of the ice deposits on the moon was an exciting one for scientists and all of the space exploration community. That's because it offered the possibility that water was readily available on the lunar landscape. This meant that astronauts could perhaps use these reserves on expeditions. Even as far back as 2009, NASA officials were eyeing up the moon's water as a potential resource for future missions. In an interview with the BBC, NASA's chief lunar scientists for exploration systems explained, "It can be used for drinking water. You can break it down and have breathable air for crews. But also, if you have significant quantities of this stuff, you have the constituents of one of the most potent rocket fuels, oxygen and hydrogen." Uncovering more information about the lunar ice deposits is something that NASA is focusing on at present. In the future, the space agency hopes to understand more about how the water got there and how it relates to the rest of the moon's surface. With that in mind, NASA is involved with a number of research projects concerning the moon. As a result, scientists studying the lunar landscape had another breakthrough in March 2019. And this time, they had discovered that water is actually in motion across the surface of the moon. The data that the scientists used in their research came from the Lunar Reconnaissance Orbiter, or LRO. This robotic spacecraft is being used by NASA to map the surface of the moon. It's presently in orbit in order to locate resources, document radiation and seek out potential landing areas on the surface. Thanks to the LRO, scientists were able to embark on the Lyman Alpha Mapping Project, or LAMP for short. This project measured particles on the lunar surface and to gain an idea of how the lunar water behaves and travels throughout the day. And the results were fascinating. As we've heard, in the past experts believed that the moon was mainly dry. Scientists thought that any water on the lunar surface existed only in the areas near the north and south poles that never saw sunlight, as had been identified by Lee and his team. But it turned out that this wasn't the whole truth. Thanks to data gathered by LAMP, scientists discovered small amounts of water that moved around on the surface of the moon. The molecules were found to be tightly bound to lunar soil early on in the lunar day, before the surface of the moon heated up. However, once it hit noon, When surface temperatures were at their highest, the water started to hop around. It seems that, after midday, water molecules are released from the lunar soil and bounce across the surface of the moon. They usually come to rest in an area cool enough for them to stick. Alternatively, they may populate the moon's barely existent atmosphere for a while. When temperatures drop again, though, they return to the lunar soil. Dr. Michael Poston of the Southwest Research Institute in San Antonio, Texas, has spent much of his career researching the moon's water reserves. Prior to working on LAMP, he conducted experiments on lunar samples, including water, that had been collected by the Apollo space missions. And this most recent batch of research had been invaluable. That's because, according to a NASA press release, it gave scientists an idea of how much energy was needed to release water molecules from the lunar landscape. Moreover, it also helped researchers understand more about how water remains on the surface of the moon. And understanding these two processes would be vital if earthly visitors to the heavenly body are ever to harness the resource on future missions. In the NASA statement, Poston revealed lunar hydration is tricky to measure from orbit due to the complex way that light reflects off of the lunar surface. Previous research reported quantities of hopping water molecules that were too large to explain with known physical processes. I'm excited about these latest results because the amount of water interpreted here is consistent with what lab measurements indicate is possible. Dr. Kurt Rutherford is Poston's colleague at the Southwest Research Institute and lead investigator of the LAMP instrument. And in the NASA statement, he also expressed his excitement over the discovery. Rutherford said, "This is an important new result about lunar water, a hot topic as our nation's space program returns to a focus on lunar exploration." Rutherford revealed how the team of scientists had used technology to follow the moon's water closer than ever before. "We recently converted the LAMP's light collection mode to measure reflected signals on the lunar day side with more precision, allowing us to track more accurately where the water is and how much is present," he explained. And insights into the way the moon's surface water moves and changes weren't the only discoveries that the LAMP team made, because they were also able to learn more about the lunar water cycle. And this in turn enabled them to rule out one theory about how water molecules came to settle on the moon in the first place. Previously, scientists had suggested that hydrogen ions found in solar winds were the source of any water found on the moon. But each time the moon passes behind the Earth, our planet shields it from these winds. As a result, this would mean, according to the prevailing theory, that the water supply would be blocked. However, LAMP scientists found this not to be the case. They discovered that the moon's surface water in fact didn't diminish when the astronomical body passed behind the Earth. This suggested that lunar water deposits build up gradually and are therefore not supplied by the solar wind. In the NASA press release announcing the discovery, scientist Amanda Hendricks explained the significance of this study. "These results aid in understanding the lunar water cycle," she said. "They will ultimately help us learn about accessibility of water that can be used by humans in future missions to the moon." According to Hendricks, the moon's water supply could be used as a resource for future astronauts. Lunar water can potentially be used by humans to make fuel or to use for radiation shielding or thermal management, she explained. If these materials do not need to be launched from Earth, that makes these future missions more affordable. The news of the LAMP discoveries was also celebrated by John Keller, a scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland. Goddard is in charge of the LRO mission, which carried the LAMP instrument into lunar orbit. This result is an important step in advancing the water story on the moon and is a result of years of accumulated data from the LRO mission, Keller said. "So, although the moon may be our closest neighbor in the universe, it seems we still have a lot to learn about it. Even with the discovery of water, in fact, many mysteries surrounding the moon remain, including its origin. And that's why NASA will are continuing to fund research into the lunar landscape in the hopes of perhaps establishing a human presence there in the future." At the very least, learning more about the lunar landscape might help us to discover more about the universe we inhabit. As Lee told CNN, given that the moon is our nearest planetary neighbor, understanding the processes which led to water ice on the moon provides clues to understand the origin of water on Earth and throughout the solar system. A future moon mission is needed to examine the whole lunar PSR's permanently shaded regions to map out all water ices and understand the processes which led to water on the moon, Lee added. This work provides a roadmap for future exploration of the moon, particularly the potential of water ice as a resource. We hope you enjoyed the video. Please let us know which one of these stories you found the most interesting. And if you like the video, click on the subscription button and turn on notification so you will be the first to know when we put out a new video. We thank you for watching, and we hope to see you next time.